I hope I'm audible and I hope we can start. Right,
Yes,
it's already 15. Yeah, we're late. Okay, so good morning, everyone. Welcome to lecture number 11 of MCA. As I told you, the portion for module for IA exam is going to be entire module 1. Okay, whatever I have taught you, you can see the syllabus. Just take the syllabus in front of you and check all the points. So we have covered all the points in the syllabus. So according to that only you will get the question for your IA exams. So as per how we have for the syllabus, that way we'll finish it off. All right, and then module 2 is what I'm going to show you today. So module 2 is what we're going to see today. Let us see how much we can finish off. Okay, it's a very a simple module 2, just basically theory based on memory elements. So major parts and all you know already. So we'll be having this lecture, and mostly tomorrow also I may take one lecture tomorrow or day after. I will let you know when is it feasible. So based on that, we'll finish off this module also. Okay, this chapter also. Okay. So I've taken reference of many different presentations to create this presentation for you. Right, I put the links up in the presentation itself whenever I have taken it from them. All right. Okay, so we're starting on memory, please. The second chapter is called as memory systems or semiconductor memories. Okay, that is module number 2. So when we talk of memory, we talk of what? We talk of memory as a place where we store anything. So in computer systems, especially in computer systems and in our embedded projects and all, we require to store memory, right? So when we write code or when we have some data, okay, or when we take in some data from the input and we put it on the output, everything is depending on memory, right? Somewhere or the other, we are going to store memory. Somewhere or the other, we are going to make use of some memory. So the easiest memory or the smallest memory that we saw, okay, that we saw in our systems was our registers, right? So registers were that one memory element which we have already accessed and used as part of our learning in module number 1. In the similar way, when I talk of this memory element over here, when we talk of memory elements, there are different kinds of memory elements. So you have seen a registers and then you saw a memory block also. So what are these memory blocks made up of and what are your registers made up of? Are there any other memory elements also that we need to consider? All these things are part of module number 2. Okay, so memory is the place where we store any element or we store our programs or we store data. Okay, so yesterday we saw two things. We saw something called as a program memory and we saw something called as a data memory. All right. Okay. So any doubts if anyone has revised module 1? Are there any doubts or any requirements as such from module number 1? Are there any requirements of module number 1? So all these presentations, whichever I have used for module number 1, I'll put them up on Moodle today or tomorrow, so that you can study for your IA exams. I think your IA exam is on Tuesday. Second exam is on Tuesday, so we can prepare for that. Is there anyone who wants to have? Is there anyone who has any doubt or something, some clarification regarding module number 1? So module 1 is basically first step is how we execute our memory elements, how the ALU and all works. Second is about using program counters, stack pointers and all. Okay, DMA, subroutines, interrupts. Then yesterday we saw about RISC and CISC, and then we saw about Harvard and von Neumann. Okay, so any doubts in this anyone has? If there are no doubts, we can go ahead. Okay, I'll consider as no doubts. Okay, fine. So memory units. So when we talk of memory units, so a bit, okay, a single bit. Okay, so 1 and 0. So as we all know, digital logic is always 1 and 0. So this entire 1 and 0 is what we consider to be how to deal with things. Okay, so 1 and 0. So if you have 1, if you have 0, so 1 and 0 is high logic, 1 is high logic, and 0 is low logic. Okay, so when I talk of high logic and low logic, it is maybe if your system is at 5 volts, it is plus 5. ये नहीं तो 0 है. System is at 3.3 volts, your 1 is 3.3, your 0 is 0. If it is a 1.8 volts, so ये आपका high है, ये low logic है. Okay, so please remember 1 and 0 are what these are logic levels. Okay, and these logic levels are decided by your system voltage. So we have something called as VIH, right? VOH. Have you heard of these things? VIL, VOL, and all. Have you ever heard of these things? VIH, VOH. Has it been taught to you ever? VIH, VOL? Yes or no, please?
No, sir.
Okay, so maybe it will be taught to you. So when you see a data sheet, so you should have seen this when you were doing your mini projects. Okay, so we have something called as VIH. What is considered as V input high? What is considered as V output high? What is considered as V input low? What is considered as V output low? So there are different levels which decide for us how do we consider 1 and 0s. So your 1s and 0s are considered based on these levels. So just open up a data sheet, maybe of your IC 555 or something like that, and just check if you can see something called as VIH, VOH. So who decides? Okay, who decides that 5 volts is 1? Who decides that 3.3 is 1? Who decides that 1.8 is 1? It is all decided by this VIH, VOH, VIR, and VOH. All right, so these are your logic levels, right? So a bit, okay, 1 and 0 is your logic levels, plus and minus, plus 5, plus some voltage and some ground voltage. Okay, that is what we'll consider as 0. So when you have 8 bits coming together, you have 1 byte. When you have 1024 bytes coming together, you have 1 kilobyte. Similarly, then 1 megabyte, then 1 gigabyte, and 1 terabyte. Okay, our main domain is to remain inside these two things. Okay, so when we are talking of embedded, we are only concerned about kilobytes, bytes, kilobytes, and megabytes. Okay, megabytes is also rare. Fine. So when I talk of embedded systems, you basically have only these two logics to take care of. Okay, your memory is going to be either in terms of bytes or in terms of kilobytes. Okay, so for example, your if you have an Arduino, okay, so your Arduino has 32 kilobytes of memory, flash memory, okay, and it has I think, yeah, it has 2 kilobytes of something called as SRAM, right? So we are basically depending on only kilobytes as such. Okay, we are never going to go into the megabyte or gigabyte or terabyte regions. If you there are embedded systems which have even 1 MB of flash. Okay, so we are not going to access that, but we are basically going to be concerned about 1 byte and 1 kilobyte. So bytes and kilobytes may our game is going to be there. Okay, so microcontroller world, it revolves around these two categories. You don't go beyond that. You don't necessarily have to go beyond that. Okay, so when I talk of memory, there are two bifurcations of memory. Okay, one is called as a primary memory, right? And another is called as a secondary memory. So secondary memory is easy to understand. Secondary memory is our external storages. Okay, for example, our hard disk. Okay, that is external storage. Then we have CD-ROMs. Okay, you have your Blu-ray disk. Okay, you have other external disk. All these are secondary memories. So what are primary memories then? Primary memories are all it is called as a main memory or the internal memory. So whatever is there as part of your system is your primary memory. Okay, in your primary memory, you have memory for registers. Okay, so ALU will have registers. Then what will you have? Then you will have your cache memory. Okay, that is your L1, L2, L3 cache. Then you will have your RAM. Okay, then you have some ROM, something like that. So all these things are part of your main primary memory. Okay, so RAM and ROM, if you talk of RAM and ROM, you will talk as your primary memory. Fine. So it is a place where the data is stored either by the manufacturer or by the user. Fine. So these are used to do your daily operations. These are not used for storages. So storage karne ke liye we are going to use for hard disk drives and our optical disk. All right. So RAM and ROM are a part of a primary memory. Okay. So one thing to remember is that people often say HDD. Okay, your hard disk drive or your SSDs. Okay, people call them as your ROM. All right. So it's a term which has been used as such. Do not get confused. We are not talking of hard disk drives over here. No, we are not talking of SSDs over here. Okay. So when I talk of primary memories, we are not talking of hard disk drive and SSDs. They are sometimes called as ROM also. Okay, your read-only memory. It is called as your ROM, but when we talk of literature, we do not talk of them in terms of primary memory. So primary memory is what? All the memory that is a part of your motherboard. Okay, all a part of your system. For example, your laptop has some primary memory, right? That primary memory is inside the hood, inside the covering of your laptop. Okay, so your RAM, okay, there are some ROMs also. Okay, so your BIOS is your ROM. So all these are there within your systems. Fine. So within your CPU, you have something called as your registers, your cache. All these things are there inside your CPU. Then you have your external RAM, okay, your DRAM, okay, your DDR4, DDR3 RAMs. All these are part of primary memories. Right? So these are located inside the motherboard of the system, or as you say, which is directly connected to the CPU. Okay. Now, secondary memory, okay, this is a place where we store our personal data. So personal data is stored inside the second memory, and these are your normal hard disk and your CD-ROMs. Right. So when we have to access this secondary memory, it has to have access even if your power supply is lost. Okay. For example, you have a system and it crashes or your power supply is lost. The data that is written in the memory has to be existing over there. Fine. That is why these secondary memories are called as non-volatile memories. So these are non-volatile memory because they do not lose the power even when if they do not lose the data even when the power is switched off. So these are non-volatile natures. That is, they are not volatile. But when you talk of primary memories, okay, majority of these primary memories are all volatile. That means you switch off your power supply and your memory is lost. Okay, that cannot be said of ROM. Okay, that cannot be said of ROM memory. But when I talk of RAM memory, when I talk of L2 cache, when I talk of registers, all these things are volatile. So you switch off your laptop or you switch off your PC, all these primary memories are lost. And when you switch them on again they get refreshed. Fine. So maybe your move A, B, A and B registers, or B and C registers, or D and E registers. All these do not store data infinitely. Okay. So whenever power supply is lost, that data is also lost. But that is not the case with secondary memories. So secondary memories are specifically locations where you can store data, and this data you can use it or retrieve it whenever it is required. And this entire data is non-volatile in nature. Okay, so we do not lose data when the power supply is switched off. Fine. So there are two methods of accessing this memory. Okay, one is by means of sequential and direct. So sequential is not used. So these were the old types, the magnetic tape types and all. So now we are using the direct method of accessing this memory, and that is by means of the magnetic disk or the hard disk and the optical drives. Okay, so either you can have physical magnetic disk drives which rotate at a certain RPM. So for example, if you talk of your hard disk, it rotates at 5,400 RPM or 7,200 RPMs. Fine. Similar way, you have newer technologies called as SSDs, okay, solid state drives, okay, faster than your hard disk and more compatible, and similar like your USB pen drives. Okay, so these are all your direct methods or your secondary memory. You're not going to use them as your primary memory. Fine. So primary memory are all the memories located inside your CPU. Secondary memories are all the data or are all the memory elements that are acting as storage elements, which can be used to retrieve data even after the system is switched off. That is basically a difference between secondary and primary. And there is an overlap over there called as ROM. So ROM, there is an overlap. In ROM memory, your data is not going to get lost even if the supply is switched off. Okay, we'll talk of this ROM memory sometime. All right, so if I talk of primary memory, RAM, okay, so RAM is called as your random access memory. So we have talked of RAM. Okay, why is RAM required for us? Okay, why is the usage of a RAM required? So for example, when you are doing some kind of arithmetic operations, when you are doing A is equal to A plus B. Yes. Okay. So for example, when you do A is equal to A plus B in your systems, okay. When you do A is equal to A plus B. Right. So for example, if I say int A is equal to 5 and int B is equal to 10, okay, then you say A is equal to 5 plus 10, and therefore A ka value it becomes 15. All right. So when I write int A is equal to B, I have told this to you earlier also. When you write int A is equal to B, int A is equal to 5 and B is equal to 10, this data is going to get stored in your memory. Okay. Maybe I will say it in your program memory. And maybe this program memory is non-volatile. Non-volatile means even after the program is switched off, even after the power supply is lost, your program is going to exist. Okay? So for example, when you switch off your mobile phone, when you switch your mobile phone again back, you again have the entire data, whatever you have used. Right? That is called as non-volatile memory. But here you see that the value of my A is equal to 5. And here you will see that the value of A has now increased to 15 when the program was executing. Right? So when the code is executing, when the code or the program is executing, the value of my variable becomes 15. The initial value was 5 and that value has now become 15. So where will you store this data when the program is executing? That data is stored inside your random access memory. That is why your RAM is very, very important and a very crucial part of your systems. All right. So your program memory. So this I will call as my program memory. Int A is equal to 5 or B is equal to 10. So these are stored inside your flash. Okay. So if I talk of embedded system, these are stored inside your flash memory. So once you store data inside your flash memory, that data is not erased even after the system is switched off. When we will use a Arduino, you will understand that when you store the program of the Arduino inside the Arduino, even if you plug off the system and again plug it on, the program remains over there. But what changes? The value of these variables, they keep on changing. So A is equal to 15 over here. So tomorrow I say A plus plus, then 15 becomes A is equal to 16. Then in the program, if I say, okay, A plus 2, then 16 becomes 18. So what are we seeing over here? We are seeing that the value of this A variable keeps on changing. So some memory has to be there in the program or there in the system which store this thing. So that is being stored by your RAM, okay, or random access memory. So what does the random access memory do for us? It stores the data which the user currently uses. You can see this. The user currently uses, or as we say it, stores the data temporarily in it. Okay, so these are temporary storage of data. So A is equal to 5 is stored where? In your main program memory or your flash memory, will say. And when the value of A changes to 15, 16, and 18, all these are stored in your RAM. That is why we say that your system should have a lot of RAM. Because when you start up new programs, when you start 10 programs in your PC, what happens? If you start the 11th program, maybe your system starts to get hanged a bit, right? Why is it? Because it is not having enough space to store the variables that the program requires. Okay, so that is the requirement of RAM. So if you have more RAM, you have more memory element to store your variable temporary data. Right. So RAM needs power, electricity to work. Okay, so important to note this: RAM needs power, electricity to work, and when the computer is switched off, the data is all erased automatically. That is why when your system, what happens when your system hangs? Okay, when your PC or your laptop hang, what do you do? The most easiest way is to restart. So when you restart, what happens? The RAM refreshes. Okay, it is called as the RAM refreshes. And if you have 4 GB of RAM, if it was using approximately 4 GB before crashing, then again it comes back to approximately 1 to 2 GB, and your system starts once again. So what is actually happening when you're restarting your PC is that you are actually refreshing your RAM. Okay, or if for example, if your memory has if your processors have increased such a lot that your memory is entirely used, then a restart is used because you need to reduce your memory consumption. We have talked of this when we were doing 8085. Do you understand this, guys? Do you understand this, please? Why do we require a RAM? Do you understand why do we require RAM? Because this is very important when you're doing programming. Why do you require RAM, please? Can I just have it in one sentence from you? Why do I require RAM? To store which kind of memory or which kind of data? If you can just give me one word for that.
Temporary data.
Which data?
Temporary data.
Yeah, temporary data is created by whom? Who creates the temporary data?
User.
Not user. Temporary data is created by whom? The user will obviously write the program, right? But it is being used by which element in your program? Which element or which section of your program requires this usage of temporary data? So when I say int a, what is your a? हम लोग क्या बोलते हैं इसको a को?
Register.
Variable, not register, right? It's a variable. When I say int a is equal to 5, it's a variable, right? So ये एक variable है. Alright, so your variables require the usage of temporary data. So when you write int a is equal to 5, it's a variable, right? And that variable requires some data to be stored, and that is being stored in your RAM. It's very important. ये बहुत important concept है, समझो आप please, okay? So if I say that, if I talk of Arduino, okay, since we're going to use Arduino on Friday, so Arduino mein there is 32 kilobytes of flash memory, okay, and 2 kilobytes of RAM memory. So I'll call that SRAM. Now, what will you store inside your 32 kilobytes? You must answer this when I ask you this thing for Arduino also. Okay, what are you going to store inside this 32 kilobytes? What will you store inside this 32 kilobytes of flash memory? Code, or what? Code is called as your
Instruction.
program or instructions. Okay, so code or program or instructions, these are stored inside your 32 kilobyte of flash. What is going to be stored inside your SRAM over here? SRAM ke andar you are going to store your variable, okay, variable ka values, etc. I hope this is clear. Okay, I hope this is clear. Right. So you only have 2 kilobytes of RAM. So if you have hundreds of variables, then your RAM usage will finish off, and your program will not execute the way it should execute. Right. So this should be more clearer when we are actually doing Arduino. Okay. So when we do Arduino, it should be much clearer that I'm going to use this. Right. Okay. We'll just all right. So inside RAM, you have two kinds of RAM. Okay, one is called as static RAM. Okay, SRAM. It is called as SRAM. So static RAM is SRAM. Fine. So what is the meaning of static? Is that the word static refers that the memory retains its contents as long as the power is supplied. Fine. So same thing. So RAM ke andar you have two bifurcations. One is SRAM and the other is DRAM. Okay. Now we are going to check what is SRAM. That is static RAM, which we say. So when I talk of static RAM is RAM which refers that the memory retains its contents as long as the power is supplied, and therefore it is volatile in nature. Okay, so volatile in nature means whenever your supply is removed or there is no supply, the entire memory gets erased and you again start afresh. Okay, the usefulness of SRAM is that SRAM does not need to be refreshed periodically. Okay, SRAM does not need to be refreshed periodically. Refreshing periodically means, for example, if A is equal to 10, A ka value 10 hai, and it is stored inside your SRAM, you don't need to again and again refresh this memory to store the data in SRAM. Okay, so it's a very special kind of storage element that is very, very costly. Okay, so SRAM is faster, but it's very expensive than your your DDR RAM. Okay, your dynamic data rate. Fine, your dynamic RAM se bahut costly hai SRAM. Right, so when you talk of microcontrollers, you have 2 kilobytes of SRAM. Okay, it is so precious. So there is 2 kilobytes of SRAM in your Arduino. All right, so this 2 kilobytes is SRAM. Okay, so we do not have anything called as DRAM as such in our Arduinos. We only have what we have something called as only SRAMs. Okay, so I will just show you this Arduino screen over here. I'm just opening this upside of my. If you talk of this Arduino screen, okay, I have just written a program over here. So maybe I will say is equal to okay, just a program I have written. I'm just compiling the program. Okay. You can see I'm compiling the program. You can see the bottom part of it. Okay. See the bottom part of it. Can you see this? The sketch. Okay. The sketch means I will say the code or the program uses 444 bytes. Okay. 444 bytes of program storage space. Program storage space I will call as my flash memory. Maximum is 32256 bytes. That is 32 kilobyte. So where is the code program stored? It is stored where, in flash or in RAM? Where is it stored, guys? Where is it stored?
In flash.
In flash. Okay, so we'll talk of flash. Okay, don't worry. Global variables use 9 bytes of dynamic memory, leaving 2039 bytes for local variables. Okay, so what is this? ये क्या रहेगा आपका dynamic memory? What is the dynamic memory? It is your DRAM. Okay, but in your Arduinos, it is your dynamically SRAM. Okay, static RAM you have. SRAM is 9 bytes, leaving 2039 bytes for local variables. Maximum is 2048 bytes. That is 2 kilobytes. So 2 kilobytes is your memory or your RAM, which is used to store your local variables and your global variables. Right? So global variables are variables that are stored outside, okay, in the main, outside the main loop, and we'll have your local variables that are there inside your functions. Okay. So if I say int, these are going to be my local variables and my global variables. Okay. So I have some sketch which uses some data over here. This is my flash memory, and then I have my SRAM memory. This is what I wanted to show you about SRAM and your flash memory. So this is your Arduino, which we'll see on Tuesday, or which we'll see on Friday. Okay. Next is DRAM. Okay, dynamic RAM. All right. So dynamic RAM is your RAM which you know. Okay? So we have this DDR3, okay, DDR4. Okay, all this is the RAM storage that we use in our systems. Okay, so your laptops have maybe 4 GB of RAM. Okay, so when you say 4 GB of RAM, it is actually DRAM. So when you say 8 GB of, it is actually DRAM. Okay, 16 GB of, it is DRAM. Okay, so 4, 8, 16 GB are all the combinations that we use to have dynamic RAM. So आपके laptops में and PCs में, whenever you buy these laptops and PCs, you talk in terms of RAM. Okay, RAM usage or RAM storage. So RAM is also volatile. Okay, RAM is also volatile. It contains data only when electricity is available. So ये भी volatile है. The difference between this D and this SRAM is that DRAM needs to be refreshed periodically. Okay, that is, you need to again and again refresh the DRAM so that the memory is, whatever memory or variable value is there, that is keeping on getting stored inside your DRAM. So it has to be refreshed periodically. That is the reason why this RAM works slower than SRAM. All right. So when I talk of cost, SRAM is very, very costly when you compare it with DRAM. All right. But when you talk of space, we normally put SRAMs in kilobytes or megabytes when you compare it with DRAMs. So DRAMs रहेगा आपका 4 GB, GBs में रहेगा. It is going to be in GBs. But when I talk of SRAMs, it is going to be all in terms of MBs. There is something called as cache memory, L1 cache, L2 cache, L3 cache. All these L1, L2, L3s are some kinds of SRAMs. Okay, so we'll talk of cache when we reach over there. Okay, so this is two things below you. You have SRAM and you have DRAM. So SRAM is static RAM and DRAM is dynamic RAM. Both of them are RAMs. So when I talk of RAM, please, both the RAMs are volatile in nature. As soon as the supply is gone, the data, the memory is emptied and it is refreshed. Okay, so you can start afresh. That is your SRAM and DRAM piece. All right. So when I talk of ROM, okay, ROM is your read-only memory. So I'm talking of ROM specifically in terms of computer systems or embedded systems. Okay, so ROM is read-only memory. That is, data can only be read from that memory. But even within that ROM, you have different kinds of ROMs. Okay, you have programmable ROM, you have erasable ROM, you have electrically erasable EPROMs and all. Okay, so all these things are also a part of ROM, even though we say only read-only memory, but you can write. Okay, you can write to this, but writing is not so easy as we write to a hard disk or as we write to a DRAM and SRAM. So read-only memory means your BIOS. Okay, so for example, you have your systems, right? You have your PCs and laptops. When you boot up your laptops or when you boot up your systems, what happens? You have some screen, right? Have you ever checked the screen called as the BIOS? What is the full form of BIOS, please? What is the full form of BIOS, please? Anyone? What is the full form of BIOS? Anyone? Okay, so when you switch on your system, right? When you switch on system, so if you are having maybe a gigabyte ka motherboard, have you seen this when you switch on your system? Have you seen this gigabyte kind of words which comes at the start? Okay, or some other manufacturer, if you have some other kind of manufacturer motherboard with you, you will have this kind of a logo. Okay, so all that is part of your ROM. So when you start your laptop or when you start your mobile phone, it has to start from somewhere, right? It cannot start from the hard disk. It cannot start from the RAM. It has to start from some memory element where we are storing some data. Okay, and that memory element is called as your BIOS. So BIOS means your basic input-output system. Fine. So when I switch on my computer, first my BIOS is triggered, and then my BIOS transfers the control to the hard disk, and from the hard disk, then I will load my OS. All right. So BIOS is a type of a read-only memory. Okay, and it is used by a computer when we just turn on our systems. Okay, so BIOS is used to just start the system and then hand over the transfer the system entirely to the hard disk drive. All right. Within this read-only memory, you have different kinds of read-only memory. You have programmable read-only memory. Okay, that is, this data is read-only, but it can be programmed, but by using some special programmers. Erasable memory is erasable EPROM. You have this kind of erasable EPROM. You have electrically erasable EPROMs. Okay, this electrically erasable EPROMs is also a part of sometimes your controller systems, and we'll talk on this when we are doing Arduino. Okay, Arduino ke time pe we are going to talk of EPROMs also. We are going to talk of SRAMs also. We are going to talk of flash memories also. So just remember this word. Okay? What is the meaning of EPROM? EPROM means electrically erasable programmable read-only memory. All right. So why is it special? Okay, why is it not equivalent to your hard disk or your SSD? Is that to program this kind of memory, you require a special kind of a system or a special kind of a method to erase that, and that method is called as electrically erasable PROM bolt. Right. So what is the takeaway from this? Okay, ROM is that you need to understand that there is two kinds of RAM, SRAM and DRAM, and there is EPROM that you must remember. So DRAM and SRAM you must remember for your embedded systems, not specifically DRAM. And for embedded systems, you must know something called as EPROM. Okay, so EPROM, and then obviously there is something called as a flash memory, which we'll talk of in some time. So flash, EPROM, and SRAMs. These three things are required for embedded systems. You cannot learn about everything, right? You cannot sit and learn about all kinds of memories. So हम लोग को जो requirement है वो ये है. You should know that every embedded system has some SRAM or some RAM. It has some flash memory, and it has some EPROM also for special purposes. So we'll use this EPROM for some special, very special purposes. आप normally Arduino use करेंगे तो you'll never use your EPROM. Okay, I'm repeating again, when you're normally using Arduino, you will never use your EPROM, but you will use your EPROM only for some special purposes when you want to store some big elements inside your systems full time. Okay, so we'll talk of this EPROM also. Okay, please remind me when we are doing Arduino to talk about this EPROM. Okay. Okay, what next? All right, so how do we classify this? Okay, so random access mein you will have your SRAM and your DRAM. Okay, non-random access mein, so when we're talking of read write memory, okay, we have random access and we have non-random access. So you have this FIFO and LIFO and all, right? So what are these? These are your registers. So you have learned of these registers, right? Your left shift, your right shift registers. So all these are where are these located, please? Where are these registers located, please? Anyone? Where will these registers be located?
CPU.
Inside the CPU, eh? Very good. Inside the CPU and all, you will have these registers. Okay? Specifically, you can call memory also as a collection of all these registers, but that is a different story. But when I specifically talk of registers, you know of registers B, C, D, H, L. All these are parts of your CPU itself. Okay, so there are further slides which go into the bifurcation. So over here, we missed out on this thing, right? So non-volatile read-write memory is EPROM, E2 PROM, flash. Okay, so flash is what we are going to see in some time. And then you have ROM. Okay, so you have Marx program ROM, you have this PROM. So for us, what is required for us? I told you, we have to think of flash, EPROM, and SR. This is sufficient for our use. And when we talk of assembly, assembly mein kaam karenge, then you will have to have these registers and all. Okay, so because assembly mein we are going to use what you're going to use specifically, you're going to use, for example, if you use move A, B, you are dealing directly with A and B registers. So that is your register level. All right, so that takes care of this. Same thing. Okay, so I have just got the good slides from different slides and I put it over here. So these are all different books. So this is Prentice Hall ka Digital Integrated Circuits ka memory ka chapter ka book. This is from an author called as Jin. I can't see the name. So different kinds of bifurcations that they have shown over here. Everything is the same. Okay, whatever we know that we have two kinds of memories, RAM and ROM. And ROM you have these different kinds of memories, flash memory and EPROM. And ROM you have SRAM, DRAM, and you have this FIFO, LIFO kind of shift registers. Okay. All right, let us just look at this architecture. Okay, how does this architecture of this memory looks like? So when I talk of a memory architecture, we have seen this, right? We have seen this in our CPU itself. When we have seen this in our 8085 itself. So in the 8085, what you will find over here in 8085, you have these memory blocks, right? So you have these memory blocks and you have this addresses. So ये है address of this memory block, ये है address of this memory block of memory block. When I talk of word, okay, so word zero can be one block, okay, or one element of your memory. So this is one location of a memory. So this can be m bits, so it can be 8 bits, or that is 1 byte, or it can be 16 bits, however you want it. But standard way you will have 8 bits, okay. 8 bits is going to form for you 1 byte. So this can be 1 byte, and it is called as word 0, word 1, word 2, and inside this you have individual storage elements. So these storage elements are what? These are your individual storage elements where you will store your ones and zeros. So this is what we had seen when we are talking of 8085. So if you have 8085 processor, 8085 processor will talk to the memory by means of the address bus, and will have an additional double bus address and data bus also. So address bus is going to go into these locations and go and access the address lines, and your data bus is going to be attached to this point over here, input output points, and you're going to have your data getting stored inside your memory piece. Fine. Now, when I have 8085 and when I have these address lines, you can see these are the address lines A0, A1 up to AK-1. If I want to access these different registers or these different memory elements or memory locations, I can either do it directly. Okay, so if I have 16 address lines, all of them can go and access these different registers. But we always use a decoder logic. Okay, so you have heard of a decoder, right? Encoder decoder logic. So this decoder logic is used to access your memory elements. And you know the decoder logic, it works on this formula over here. Okay, k is equal to log 2 to the power n. Right. So if I have, for example, if I have n lines, okay, so if I have n lines, so if n is equal to 64, so if I have k is equal to log 2 to the base 64, that is log 2 to the base 2 raised to 6, that is 6. Okay, so I will have 6 select lines over here. So 6 select lines will be used to access these 64 address lines. Okay? And in this way you will do it. Right? So if, for example, if these are your 64 address lines for each of these memory locations, so you will require how many? You will require 6 select lines to access your 64 address lines. So generally we have what we have around 1 MB, okay, 1 megabyte, okay. You have 10 raised to 6 address lines. For 10 raised to 6 address lines ke liye, you will require 20 select lines. Okay, so what is 1 MB? 1 MB is 2 raised to 20, right? So log 2 to the base 2 raised to 20 is 20. So you will require 20 address lines to access 2 raised to 20. That is 1 megabyte of memory locations. Similarly, if I talk of if there are 65,000 memory lines, 65,536. So 65,536, that is n is 65,536. How many select lines, how many address lines are required over here? I will require log 2 to the base 2 raised to, what is 65,536? 2 raised to 16, right? That is 16. So I will require 16 address lines. So in this way, we decide how many address lines you want. So your address lines are going to be 16, and 16 address lines can access 65,536 memory locations. So this decoder is used to reduce the number of select lines. So select lines kya hai? It is your address lines itself. Okay, so 16 address lines or 16 select lines can target 65,536 memory locations. 20 address lines can access 1 megabyte, 10 raised to 6 locations. 32 bits can access 4 gigabyte of memory locations. Or we'll say 4 giga memory locations, not gigabytes, 4 giga memory locations. So 32 bits can access 4 giga of memory locations. 20 bits can access 1 mega of memory locations. 16 bits, 16 lines can access 64,000 memory locations. Fine. And who creates this kind of a logic that 32 lines can access 4 gigabytes? It is a decoder. So this decoder logic is required to access your different memory locations. Fine. So 8085 has 16 address lines or select lines which go over here. And these 16 address lines are used to access 65,536 memory locations. Is it clear? Is this understanding clear, please?
Yes, sir.
Yes. So 20 address lines will access 1 megabyte. So please remember these words, please. 16 address lines can access 65,000. Right. Okay. How many memory locations can 22 address lines access? Let me see if I'm getting this properly. If I have 22 address lines, what is going to be the memory location that I can target? Anyone? If I have 22 address lines or select lines, how many memory locations can I target? What is 22? Is it K or is it N? What is 22? Is it K or is it N?
K.
K. N क्या है फिर? 22 is equal to log 2 to the base N. All right. So what is N? What is N then? What is N?
2 raised to 22.
2 raised to 22. How much is 2 raised to 22? You don't have. You should not use a calculator. You must know these things. What is 2 raised to 20? हमने अभी किया ना. 2 raised to 16 क्या है? What is 2 raised to 16, please?
64,000.
64K. What is 2 raised to 20? 1M, right? 21 क्या रहेगा? See, it is all in the powers of 2, right? So double होता रहता है, right? 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192. Then कितना है? 16,000, 32,000, 64,000, right? Come on. What is 2? 2 is 21 कितना रहेगा फिर? What is the double of 1M?
2M.
2M. What is 2 is 22 then?
4M.
4M. And it goes forward, okay? 8M, 16M, 32M, okay? Then it comes to 64M mega, 128 mega, 256 mega, 512 mega, and then 1024 mega. So what is 1024 mega or 1 gigabyte? 1 gigabyte is 22, 23, 24, 25, 26, 27, 28, 29, and 30. That is 1024 megabytes. Okay, please, you must know this. You must know these things. Otherwise, you make a chart in front of you and just do it. Is it okay?
Yes.
Yes. I don't know whether it's okay for everyone, but I will accept that one. It is recurrently occurring, right? This, they have not optimized Zoom for Linux. It's very bad, right? All right. Okay, so this is the same thing, okay, which we had talked of. I'm audible, right? Is it fine? Audible, hai na?
हाँ sir.
Yeah. Okay. Let me just. Okay. So this is how your RAM looks like. Okay. So if I talk of SRAM, okay, I just wanted to tell you about this. If I talk of an SRAM, so you have a 6 transistor SRAM. You can see there are 6 transistors SRAM over here. One MOSFET, one MOSFET, 1, 2, 3, 4, 5, 6 MOSFETs. Okay, so this is called a 6T SRAM. Okay, then you have a 4 transistor SRAM over here. Okay, 1, 2, 3, and 4. So these are different kinds of SRAM. Okay, this is not required for you in your syllabus. I've just put this so that you know, okay, kaisa dikhta hai these things. This is a 4 transistor DRAM, 3 transistor DRAM, and all. All right. So I just want to touch base on cache memory, and then we'll stop. Okay. Okay. Please log into Academy and please log into the new class. Purana class I didn't check in, so it has gone. The new class, please log in karna. I will just start it up. It's a class which starts at 9/7. So just for your information, just log into the application at 9/7 ka class. Okay. All right. So when I talk of memory hierarchy, so we know about memory hierarchy that registers are a part of your CPU. Then you have internal and main memory that are part of your RAM and ROM. And then you have external memory, that is your outer hard disk. Okay, your external hard disk. So external hard disk is your CD-ROM and all. Then you have internal main memory, that is your ROM and your RAM. And you have cache and you have CPU. Now, if I talk of the hierarchy of this, okay, the hierarchy of this looks like this, please. Okay, you have your storage, that is your CD-ROM, your tape, and all these things. Okay, your magnetic disk. These are all your outside storage. Then you have your inboard storage, that is your RAM and your ROM. Okay, your BIOS, your flash. Then you have something which is there inside the CPU, and that is registers, cache. Okay, so what are cache memory? Cache memories are used to access. That are used to speed up your systems drastically. Okay, so if I talk of a Pentium 3 or when I talk of a Core i3 and all, you have these cache memories. So if I talk of registers, this sabse andar hai, this there inside your ALU, right? Your ALU, or this are there inside your CPU. Then you have this L1 cache and L2 cache that are there also in part inside your CPU. Okay, and these are your SRAMs. ये सब आपके SRAMs है. L1 cache, L2 cache, अभी L3 cache भी है. So level 1, level 2, and level 3 cache is also there. What is main memory? Main memory is your DRAM. Okay, DDR3, DDR4 is your DRAM. Then you have disk cache. Okay, disk cache किधर है? Disk क्या है आपका? It's your hard disk drive, right? And what is disk cache, please? Disk cache means ये hard disk के अंदर itself you have a cache. So hard disk के अंदर itself you have maybe 8 MB of cache and so on and so forth. All right. So that is your memory hierarchy. So you have registers, L1 cache, L2 cache, main memory, then disk cache and disk. All right. Now, what is this cache memory? You can see this cache memory over here. Look at this diagram over here. So ये CPU के अंदर है, okay? Inside the CPU itself, you have L1 cache, L2 cache, L3 cache. So, and all of these three things are your SRAM. Okay. So between the CPU and the main memory. What is the main memory, guys? What is the main memory? Is it DRAM or SRAM?
DRAM.
DRAM, okay, dynamic RAM, okay, our DDR3, DDR4 ka RAM slots. So DRAM and CPU and DRAM ke beech mein you have something called as this SRAM, L1 cache, L2 cache, and L3 cache. So these are used to store your variables so that they can be retrieved faster. Okay, for example, in your computer, in your laptop, when you open up one program, okay, when you open up a program and you close it, right? then you again open up the program, it opens up faster than the earlier instance, right? So that is so what is the meaning of that? That program was initially stored in one of these cache memories, and then you could retrieve it fast from the cache itself. So if you have something in the cache, it is retrieved faster than what is it if it is in the DRAM. So SRAM is very costly. Isliye you will find level 1, level 2 cache and all in terms of megabytes only. And DRAM is in terms of gigabytes. I hope this is clear. Okay, so what all have we learned? We have learned of the CPU ka register cache, register level registers also. Then we have L1, L2, L3 cache, and then we have this main memory. So DRAM, SRAM, and registers. Uske bahar, what do we have? We have this disk. Okay, so you must know this. Okay, ये है आपका CPU के अंदर, ये भी CPU के अंदर ही है. It's a new thing. Please, cache memories. Main memory is your DRAM. Disk, cache, and disk is there as part of your hard disk drive. All right. Okay, please check into the application. I will take your attendance now. Okay, you can have a look at this screen, which talks about the increasing level 1, L1, L2 cache when we go forward. Okay, so you can see when we are in this Pentium 4 ka era and when we are in this Pentium 486 ka era, wo time pe your L1 cache was in kilobytes. It has increased to kilobytes, and now you have even 1 megabyte of L2 cache. Okay, but very costly systems. So please check in this to the application. I will take attendance. Bhagesh, Divya.
Present, sir.
Present, sir.
Omkar Munde.
Present, sir.
Okay, Shivam, Shivraj.
Yes, sir.
Yes.
Present, sir.
Present, sir.
Adarsh, Aditya.
Present, sir.
Aditya.
Sir, present, sir.
Jaipreet, Hassan.
Present, sir.
Present, sir.
Pranjali, Pratham.
Present, sir.
Present, sir.
Rakshita, Rishi.
Yes, sir.
Rakshita.
Present, sir.
Sakshi, Sanskar.
Present, sir.
Present, sir.
Sarika and Satyam.
Present, sir.
Shriya, Siddhant.
Present, sir.
Present, sir.
Both the Simran, Ananta and Simran Koparkar.
Present, sir.
Umer.
Present, sir.
Okay, fine. So thank you. We have finished off quite a bit. 2.3 tak hum log khatam kiya. Tomorrow I will continue with this cache memory and then we'll finish off with the virtual memory. So tomorrow's lecture will be a short lecture. If it is tomorrow or day after, I will let you know, right? So please come for one more lecture before your IA exams. Okay, so thank you very much for your patience. I hope you have understood. Was it clear? I mean, the bifurcations was very clear, at least on a broader level. Was it clear?
Yes, sir.
Yes, sir.
Thank you very much. We'll meet tomorrow or day after. Okay, I will let you know. Thank you.